Hello, everybody. Welcome to another installment of A Rebel Without Applause, coming to you from, what can I say, my little nutshell of infinite space right here in the Wood of the Holly. And as part of my larger project to get my PhD in everything, I have an incredibly important and esteemed guest today. He is an American paleontologist and paleobotanist from Harvard University. His research and writings focus on the early history of life. And I'm not talking about the 1950s. I'm talking way back. I'm talking about the evolution of Earth's surface environment spanning the Archean and Proterozoic eons. And he's especially interested and has devoted the better part of his intellectual life to the early evolution of microbial life and the emergence of complex organisms at the onset of the Cambrian explosion. He is the author of many books, two of which I just finished. One is A Brief History of Earth, and more recently he wrote Earth and Life, a 4 billion year conversation. He's with me on the other side of this digital divide. Welcome to A Rebel Without Applause, Andrew Knoll. How are you?
I'm fine. Thanks for having me.
The subtitle of the book, Earth and Life, this conversation, what is that conversation?
Let me start out to answer it with just giving you a little bit of a boy's own story that, when I went to college, I had no idea what I wanted to do in life. And that wasn't a popular subject at home when I would talk to my father. And so the first semester of my sophomore year, I just took a whole bunch of science courses just to see if something would attract me. And two things did. One was a course in geology. I just got excited about the idea that the history of the Earth was written in rocks all around us. And if you knew how to read it, that would be a fascinating thing. And the other was a course in biology. And I must admit that I was sitting in my room one night, and it dawned on me that maybe these weren't the separate universes that they seemed to be from the way they were taught. Maybe if I wanted to know something about the history of life, I would do well to know something about Earth's physical history and vice versa. And that really started me going. And what I mean by the conversation between Earth and life is that almost anything that you care to think about in your daily life, whether it's the amount of oxygen in the atmosphere or the shape of streams, you name it, is shaped jointly by biological and physical processes. And that in some ways is probably why we're here, because Earth has had this, persistence of life over 4 billion years that has interacted with physical processes, and we're the result.
So I'm reminded of I don't know if it's a biblical term, but dust to dust, because indeed, I guess we all make that journey. When you think of geology and rocks and biology, they feel like they're in very different categories. They're two different processes. But indeed, as you describe in your book, they're part of a larger dance. And
exactly right.
And I found that fascinating that one process informs, the other. And I'll tell you, one of the pleasures of of just doing this deep dive into deep time is it takes your mind off the next election cycle. You're dealing in different sort of worlds.
Yes.
So you went to Lehigh in the wilds of Pennsylvania. Don't they turn out engineers and, mining experts? So there must be some geological emphasis over there.
Yeah, I mean, they have a pretty good set of science departments. And to be honest, the reason I went to Lehigh is because I didn't know what I wanted to do, and I was pretty good at math. So I thought, well, let's be an engineer. And then after a year, I realized that engineering and I weren't cut out for a long relationship either. And fortunately, there were some good biologists and some good geologists there.
As I was reading your book, I have a conception of these things, but when I get into the chemistry of, the big players in this primordial soup, by that I mean nitrogen, carbon, oxygen, and phosphorus, to name just a few, this primordial soup that I guess we emerged out of, it begs this central question is like, how and why did this conversation, get started? It still seems, I guess, kind of mysterious. And
well, I think one thing to recognize, and you just think about your own body, that, about 40% by weight of the dry weight of your cells is carbon. And that carbon not long ago was in the atmosphere as CO2. And a plant took it in, made it into organic matter, and that either feeds us directly or feeds the animals that we eat. And when most things die, the organic matter in their bodies will be returned to carbon dioxide in the atmosphere. So carbon, oxygen, nitrogen, phosphorus, you name them all, they continually cycle back and forth between the earth and life. And the origin of that conversation comes when certain chemical processes give rise to structures that can actually replicate themselves and grow and feed on these elements that are in the environment.
Right. And as you point out in your book, that most of our history of life on Earth precedes our multicellular ancestors. It really lives in this microbiological realm. I'm just curious, the fossil evidence of that, how do you find that? It seems scant to me.
Well, fortunately, I worked in graduate school with a man named Elzo Barghorn, who did something that no one else could ever do. He, with one paper describing bacterial fossils from some 1900 million year old rocks in Canada, he tripled the known length of the fossil record. And that opened up, a sort of cottage industry where a number of people from many countries have looked at, actual microfossils of tiny organisms that are well preserved in these rocks, in chemical signatures that are also well preserved, and in certain structures. There are structures called stromatolites, which form when microbial communities on the seafloor actually build up and accrete sort of a three-dimensional structure. And those tell us that life has been around, probably for 4 billion years or so. And as you point out, most of that is the history of microbial life, that things like animals and plants are relatively newcomers in our planet's history.
Yeah, these guys, which are seemingly ancient, are Cretaceous era friends. There's just like a second before yesterday, apparently.
Pretty much. And again, I think that unfortunately, if we know anything about bacteria at all, we know that they cause disease. And that's probably 1/10 of all bacteria that do that. And most of the bacteria, which in terms of metabolism, the way they make their living, are far more diverse than animals or plants. And it is really all the things that bacteria do that in some ways keep the earth habitable. For years, I used to tell my students that bacteria don't need animals, but animals certainly need bacteria.
What you're talking about to me is part of, this awareness of this invisible world of life is part and parcel of kind of like an intellectual revolution of sorts in terms of our understanding of the world. And I kind of want to go over some of these revolutions because they're a big part of your book. You sort of have the revolution of geology, stratification, and like, whoa, this Earth's got to be way longer. You have Darwin and his understanding of the planet and evolution. And by the way, just reading your book, Darwin's a poet too.
Oh, if you read The Origin of Species, it's beautifully written. It's not only smart, it's gorgeous.
Yes, he's almost like at Shakespearean levels of expression and understanding, And there's a quote. I wish I could read it. I thought I want to learn that quote because I want to perform it. But just about this, sublime beauty and this, evolutionary tree. But we're talking about intellectual revolution. So we have geology, Darwin, and then of course, Einstein and relativity and all understanding of chemistry and radioactivity, but also in our own lifetime, the understanding of tectonics and how that has informed your work.
Absolutely, yeah.
And I'm just curious how that affects you. It's all moving,
Well, no, it's funny that the so-called plate tectonic revolution, which, as you say, is what really controls where there are mountains, the shapes of ocean basins. It's an extraordinarily powerful theory of everything we see around us in the physical world. That was just coming online. There were some people back in the 1930s who proposed it, but it wasn't very popular until people started getting information from mapping the deep sea floor, which actually started to try and find German submarines during World War II. And then they found that there was basically a mountain range running down through the center of the Atlantic Ocean. And that opened up all sorts of new ideas. And that was just coming online when I was a student. And it was very exciting because, you weren't learning stuff that was in fusty old textbooks. You were learning stuff that nobody knew 5 years before that. And that, that's exciting.
And there were some hints of it. I think even, was it, I know you mentioned this in your book, Darwin's contemporary Wallace, had made some suggestions about, because he could observe different, evolutionary paths as he made his travels across certain geographic, boundaries. And a simple look at a map, you would look, is that South America? It kind of fits, and
that's the funny thing, because when those ideas were first put forward in a serious way, all the great and the good at places like Oxford and Cambridge and Harvard, that kind of thing, just they couldn't believe it, because the thought was that the continents had to plow through the ocean floor as they moved. And they correctly said, well, they can't do that. And then a guy named Harry Hess from Princeton came along beginning in the 1940s through the 1960s and pointed out that there are these, so-called the mid-Atlantic ridge, where you have new ocean crust forming, and that pushes the continents apart. So the continents are actually just, they're in some ways just sitting there, and the oceans are pushing them apart. And of course, since the planet isn't getting bigger, if the Atlantic Ocean is growing, other oceans have to be losing some of their seafloor, and that happens when the ocean floor actually dips down back into the mantle. And what we see, if you look around the Pacific Ocean, it's sometimes called a ring of fire, because it's almost completely surrounded by volcanoes, and they tell you that Pacific Ocean seafloor is disappearing beneath the continents.
Well, and I was thinking about that because so much of the fossil record, in the Proterozoic, we're talking about from like 540 million years ago back to like 2.5 billion. It's a huge swath of time. It would seem to me that much of that fossil evidence has already been subducted back into the bowels of the earth.
The bad news is you're right. The deep sea floor, I think the oldest deep sea floor that we have today, for the most part, is a couple 100 million years old, and the rest is gone. The good news is that continents don't subduct, so records from the continents have a much longer lifespan. Now, it turns out that nature writes the history of the planet with one hand and it erases it with the other. So as you go back further in time, we have fewer and fewer rocks that we can look at usefully. But to me, the remarkable thing isn't that there's so few of them. The thing is that, I know there are places where I can go in southwestern Greenland and actually look at rocks that were formed 3.8 billion years ago. And that's a remarkable thing to think about.
And even more remarkably, you may not need a passport soon to go there.
Oh, let us hope.
With the global warming, it could be a 10,000 hole golf course, pretty soon. That's that's another story. That's why we delve into the deep time, since we don't have to worry about the current moment. Although there's some interesting echoes that you talk about in your book between deep time and our current times. Hello, friends, countrymen, and subscribers. After a number of years doing this podcast, I finally have a promotional partner, and the company is called Cozy Earth, and they make all manner of bamboo bedding for your sleepy time needs. That includes pillowcases, duvets, sheets, and even pajamas. And I'm able to offer you a 21% discount on any and all purchases from Cozy Earth. All you have to do is type in the promo code REBEL to get that 21% discount. Now, I've been using these bamboo sheets from Cozy Earth for, a couple of years now, and I can stand behind it because I sleep on it. So all you got to do is, like I said, type in the promo code REBEL, go to the Cozy Earth website, and you can get a 21% discount and support sound sleep while you support me. Dig it, Daddy-o. You know, I read a book years ago recommended by a friend, and I'm sure it was almost biblical for you, and that is Wonderful Life, about the Burgess Shale.
Sure.
At the dawn of the Cambrian explosion and the travels across, the Paleozoic to the Permian extinction, another big swath of time and extinctions. And when I was reading the book, and I think they talked about this, is that the evolutionary sort of thing was less a tree and more just this wild friggin' bush of experiments and crazy things that didn't quite make it, and a few that actually their body plans sort of survived. But your book feels more, you're more into the tree metaphor of life.
Well, yeah, I think I'll stick with that tree metaphor, which again goes back to Darwin. And what it really says is only that there was one origin of life, and all of the life that we see around us, from bacteria to humans, is descended from that. And what happens is that two populations diverge and become different from one another. One of them may actually then evolve multicellularity and the other one not. And so I don't think Steve Gould would argue strongly against the tree metaphor, but he would draw attention again to something that Darwin said, that the tree of life has many branches which died and are now just lying as sticks at the base of the tree. And there's a lot of fascinating information about evolutionary history in those. I mean, dinosaurs, for example, trilobites, all these things, they aren't with us anymore, but we learn a lot about life that we can see and feel on the planet today from them.
Right. And indeed, and correct me if I'm wrong, the DNA that lives within us is connected all the way back to these root life forms. I mean, we are these genetic handoffs through the millennium. I take personal comfort that since I have no kids, that it ends with me. I am destined to extinction.
Yeah. I'm glad you brought that up, because there's a whole relatively new way of looking at the history of life now that comes not from fossils. We need that record, but in addition to that, there's the comparative biology of the genes and genomes of organisms. And there's a huge amount of information showing the relationships through time of different groups. We can make estimates of when, let's say, photosynthesis began based on the rates at which those genes are becoming more different from one another. So the rich history that we have now of life really reflects both the geologic record and this genetic record.
How exciting for you to be
it is.
At ground zero for all this stuff. I was thinking as I read your book, in human history or modern history of civilization, we divide it before the Christian era, before Christ, BCE, and after AD, after Dominion, right? That's where we divide our time frame. But if we're looking at the history of life, and I was looking at it, I think we should have BGOE and AGOE. And for my friends out there, I have no idea what I'm talking about. I didn't either until I read this book or these books. We're talking about the great oxidation or oxygenation event.
I think there's two great inflection points that divide, in some ways, Earth history into three big chapters, and they both have to do with oxygen. So one of the things that's become apparent over the last 50 years or so is that for the first 2 billion years of our planet's history, most of which Earth was a biological planet, there was little, if any, oxygen in the atmosphere. And today we still have many different types of bacteria that don't use oxygen, and photosynthetic bacteria that don't create oxygen. So we still have types of organisms that would have populated the early Earth. And then there's 6 or 7 different lines of geological evidence for when we started to have a world that had oxygen in it. And they all agree that it happened between about 2.4 and 2.2 billion years ago. And again, at least I think that that has to do with tectonic things. There's record evidence that continents emerged from beneath the sea that would put a lot more nutrients, particularly phosphorus, into the oceans, more photosynthesis, more oxygen. Now, the interesting thing about the so-called GOE is that when it was over, there was still only 1 or 2% of the oxygen that we have in the atmosphere now. And that stayed low until about 600 million years ago. And then there's evidence that it built up over probably 200 million years to what we have today. And that again seems to reflect the effect that changing tectonics had on the supply of nutrients. So in some ways, this story of oxygen is really almost the epitome of Earth and life in conversation through time. And that's why we have animals. You need more than 1% of today's oxygen levels in the atmosphere to have, oceans full of animals. And perhaps not surprisingly, when we first started seeing geological evidence for increased oxygen, that's when we first start seeing animals.
So I know when I fill up my scuba tank with air, it's like 19 or 20% oxygen, and
that's right.
The rest of it's nitrogen. And if you really just deep diving, you can do nitrox diving, get it up to 32%. But then you could get oxygen poisoning too if you're not careful. So I guess we tread this balance. And as you describe that, it feels like then oxygen, as it enters the atmosphere, either through photosynthetic processes or chemical processes in geology, I'm not sure how, but
mostly photosynthesis, yeah.
Mostly photosynthesis, that it's really creating a rocket fuel for life.
Yeah, no, that's right. Because, you and I get the energy we need from what's called aerobic respiration. That is, we take sugar molecules, we react them with oxygen, and that's then used to generate the energy you need. And, particularly for the first animals that really needed a lot of oxygen were the first carnivores, because, to hunt something down, and some of these early animals swallowed prey that was half the size of the predator. And so there's this tremendous oxygen demand when you do that. And so again, oxygen makes these things possible.
And that would have been, we're still talking about a pre-Cambrian moment.
Probably the carnivore revolution, and the major revolution of when we first start seeing all the kinds of animals that we still see today, arthropods, mollusks, worms, things like that. That's mostly a Cambrian event.
Okay, so by that time, the oxygen levels are at maybe not the same, but they're at a sustainable level to fuel this kind of behavior.
Yeah. Again, if one of the things, I had a very bright postdoc named Eric Sperling who teaches at Stanford now, and he did this interesting exercise where he looked at a series of ecological surveys along decreasing oxygen gradients in the present day ocean. And it turns out that once you have about 10% of present day levels of oxygen, then you have most of the things in the ocean, fish, all sorts of predators, things like that. And that was reached again at the very end of the Precambrian and into the Cambrian. And then it goes up a little bit. And that's when we first start seeing, rather than fish that are 6 inches long, we start seeing fish that are 6 meters long, that kind of thing. So yeah, no, it's a story that has really developed in the last 2 decades, let's say, and it's a pretty compelling story of the planet.
I'm a surfer and I'm in the ocean all the time. And sometimes during the year when there are these upwellings of big temperature changes, and that the water becomes anoxic, or it begins, and there are these toxic algae blooms and big fish die-offs. You just see them.
Yeah.
And so as I kind of assemble this narrative in my head, I'm thinking, well, things are happening in different places at different times. And so I have actually just observed, like, oh, the oxygen levels went down, and then there's this big fish die off in the lagoon or in the estuary, or in some of my favorite fly fishing rivers where the oxygenation for various reasons gets below a certain level, and you have a near extinction event locally.
Yeah, there's no question that the environment is not uniform across the whole planet and never has been. So when I say there was little, if any, oxygen 3 billion years ago, there were probably lakes that had some oxygen in it, but there wasn't a lot, and it wasn't global, and it wasn't permanent. But you're right. I mean, the thing that I always think of is what they call in the Gulf of Mexico dead zones. And dead zones occur because when farmers put fertilizer on all the wonderful fields in the Midwest, only about a third of that ever gets into the crops. And the rest gets washed down through the Mississippi. It comes down and it does fertilize, but it fertilizes our algae in the ocean. And then you get this huge bloom of algae. They die, and the organisms that eat them deplete the oxygen. And so within your lifetime and mine, the size of the dead zone in the Gulf of Mexico has gone from maybe something the size of Manhattan to something, now the size of New Jersey.
Well, one of the big tent poles in your journey across Earth's lifespan are ice ages and extinction events.
Mm-hmm.
I often think of the Cretaceous extinction event with the asteroid as the worst day in the history of Earth and the best, because without that catastrophe, there's really no space for us to kind of emerge across this divide. Seems like you've done some deep dives into these extinction events going back.
Yeah, the one that I'm particularly associated with is one about 252 million years ago at the end of the Permian period. And that was the biggie. That
Yes.
Something like 90% of all this animal species in the ocean disappeared. And, there had been a lot of documentation of that, and people had ideas, but nothing seemed to provide a good explanation. And, I was just at a meeting one time, and the person who was giving a talk showed this picture that he wanted to talk about these microbial structures called stromatolites, but what he showed was crystal fans that were growing up from the seafloor of calcium carbonate minerals. And I looked at a friend of mine who was sitting with me, and we both realized that these were showing that things that were widespread on the earth 3 billion years ago come back transiently at the time of this extinction. And we started thinking about what might drive that. And we had all sorts of ideas, frankly, most of them wrong. But it was hard to get away from the idea that somehow you needed to have a big increase in carbon dioxide in the atmosphere and oceans. And then another friend of mine and I went, and literally we spent 3 months in the library reading about, turns out there were hundreds, if not thousands, of physiological experiments just saying what happens when you douse an animal population with CO2. And we came up with a sort of list of those kinds of organisms that we thought should be vulnerable to rapid increase in CO2 and those that should be tolerant. And it turned out to give a very good accounting for what happened at the end of the Permian period. We now know that, in fact, it was CO2 and it was driven by huge volcanism, something well beyond anything humans have ever experienced. You had, what, 2 kilometers of lava over an area the size of Australia, now in Siberia. And what keeps on coming back to me is, besides volcanoes, there's really only one other process that can drive CO2 up very rapidly and very markedly like that, and that's technological humans. So, in a way, it turns out that what happened at the end of the Permian period, 200 and some million years ago, actually provides a distant mirror on what's happening in the 21st century. We are living at a time of geologically unusual carbon dioxide increase, and we're just beginning to see the effects of it now. But for the rest of your life and the life of the next 2 generations, that's going to be a big deal.
Right, with little or marginal volcanism to account for it, obviously.
Yeah, that's right. People have done all sorts of modeling. Can we explain it by volcanoes? And, we have a pretty good understanding of what volcanoes have gone off in the last 300 years. Could it be, you talked about upwelling and things like that happen in the ocean. We know when those have happened, and you can't explain what's going on in the atmosphere now without basically blaming it on fossil fuel burning.
Because we're in the Anthropocene, right? And
exactly. Yes.
I'm not sure when that began. There's some debate about when humans have begun reshaping this planet. I talked to one guy, I forget his name now, that he was convinced it was when the Clovis people arrived and started reshuffling the environment. He may be right, but I tend to kind of fall on the Industrial Revolution and maybe the Petroleum Revolution. And when we see this global warming that you're talking about, this CO2, we're basically, and you help me because but we're basically tapping into this Carboniferous period, Devonian, Carboniferous, where all this plant life that captured all this carbon is being re-released into the atmosphere. We're burning it. We're living on it. It's fueling our society and civilizations. Am I right?
Yeah, no, that's right. Coal in particular. I mean, the Carboniferous period is well named because that's when much of our planet's coal, certainly everything you find in West Virginia, Pennsylvania, Ohio, Illinois, was formed. And, we are using that up at high rates. Oil forms over a much wider range of time intervals. But again, the rate at which more coal and oil are forming is negligible relative to the rate at which we're using it up. And people, not, fuzzy-minded academics, but oil geologists have really sort of mapped out the rate of discovery and use of petroleum. And, by the time that my grandchildren are my age, one of the reasons you want to, take it easy on fossil fuel burning now is there won't be any left unless we are more reasonable in what we do with it. So I don't think we have all the answers for how to get to the next stage of environments for our children and grandchildren, but there are a lot of ideas out there. There are pilot plants to remove CO2 from the air. And I guess what gives me some optimism is that in some ways it was human ingenuity that got us into this mess. And I think human ingenuity is our best bet for getting out of it.
Well, I had this discussion with my sister because she loves her garden. And has this what's natural and what's not. This is natural and this is not, and this has chemicals and this doesn't. I go, well, Cindy, chemicals are everywhere. I mean, chemicals drive everything on Earth. But this idea of what is natural and what's not, and I asked her, I go, is human intelligence any less a natural phenomenon than a bear shitting in the woods? And she didn't have a good answer. Maybe you do.
Well, I think you're right. I mean, in the sense that human intelligence is a product of nature. I think if there's a line between what's natural and what's not, it's when, as you pointed out, the Industrial Revolution, when humans start making things that are not found in nature, but which have an effect on nature. And of course, people were making chariots 3,000 years ago. It's not like humans just picked up their tools in the 19th century, but the scale of human activities that I think are not natural in that sense is now so absolutely huge. I have a friend in Tel Aviv named Ron Milo, Ron just lives to quantify things on Earth. And he actually published a paper a few years ago in which he argued pretty convincingly that if he took the total weight of all the things that humans have made on this planet, it's actually larger than the total weight of all the organisms on the planet. That takes some getting used to think about the scale of human activities.
Yeah, well, I grew up in a time where, the emergence of this environmental movement wasn't always there. I mean, we're probably of similar ages. And very often the narrative is hopeless. But I have seen many examples where things have been remediated, rivers have been restored.
Absolutely.
And it isn't necessarily a one-way street to destruction and oblivion. There are examples of reversals and better outcomes, I think.
No, you're just right. And one thing, I have a lot of friends who are conservation biologists, and pretty much to a person, they realize that when they just talk doom and gloom, everyone said, there's nothing we can do about it, too
Right.
bad. But if you start to sound with some well-placed optimism because of all the things you mentioned, that, there's examples of things where we have fixed ecosystems and saved species in that, and what we as a species are capable of, I think that's what justifies, my sort of, it is optimism. I think, we have no other choice than to do something about it.
Right. And it has to be collective.
Yes.
It's not.
And it's not cheap, although the price of doing nothing will, by the end of the century, be much higher than the price of doing something. So there are even economic reasons why you would want to do this. It's not just saving the buffalo.
Right. And by the way, I like the buffalo. I mean, I want to say buffalo. They've restored the prairie in certain ways. You worked on the Mars mission, and you didn't get to go to Mars. Apparently, there were some weight limitations on who could go. And I guess you were there for the purposes of seeing, well, maybe there's some microbial action up there on the red planet. And I didn't come away with a conclusion.
Yeah, I was on the science team for the first rover mission to Mars, the MER mission around, the 2 decades ago. And that mission was not equipped to look for evidence of Martian life, but rather to look for evidence of Martian environments in the past. And they needed people who could read rocks the way we do on Earth. So fortunately, I was one of the people who was asked to join that. And it was fascinating. One of the things that I think we found, and I've actually worked on this with a modeler friend of mine, is that it looks like, the old narrative was that Mars was warm and wet for 600 million years early in its history, and then it slowly dried out to produce the kind of desolate planet we see today. And what we think, and I think the rock record actually supports this, is that Mars was warm and wet for 100,000 years every 20 million years for 600 million years. So it's this episodic habitability, which, of course, has very different implications for Martian life. I don't think we know whether there was ever life on Mars. I think if there was, it didn't persist. And certainly in nowhere in our solar system has life transformed the planet the way life transformed the Earth?
Yeah, we are in a serendipitous sort of little space
Yeah.
in our solar system. It seems to me, I mean, that's pretty obvious. Like
Yeah.
I'm reminded of like being in the desert, and then there's a little oasis around which teems some turtles and frogs and some palm trees, and I think Earth is like that,
Yeah.
and maybe there's another oasis out there,
And I
beyond.
think what we've learned about places like Mars helps us to underscore the fact it's not just that life took root on Earth, but it's persisted for 4 billion years. And, when people ask about life in the universe, they're always asking about, well, couldn't life actually originate many places in the universe? And the answer is probably yes, but only a very small subset of those origins might persist for the long intervals of time that we have on Earth. So it might be that persistence that makes Earth special.
And in part and parcel of the persistence that you talk about, and just sort of as I've imagined, like human evolution and evolution in general, is with these big extinction events, you get these small colonies of survivors,
Yeah.
and they get this blank canvas. And it seems like when there's that blanker canvas, there's just like an explosion of evolution and activity and variation and growth and opportunity and niches to fill. And like maybe before the asteroid, it's pretty crowded. I'm a mammal. I really want to stretch my wings. I want to get out there, and I have potential, but there's no room. It's sort of how I feel like in Hollywood. And it took
No, you're just right that one of the things that accompanies an extinction is that the survivors have this ecological opportunity because the Earth isn't so full that pretty much every mutation will be bad. So absolutely, and as you say, the world that we see around us, which is full of mammals and snakes and things like that, is a world that took shape after the dinosaurs disappeared.
Yeah, Steve Bersati's world. You're way before
Exactly.
Steve Bersati. We'll get to him. I'll get to him shortly. I live here in the Wood of the Holly in this movie colony, and I did read where you had an opportunity to work with Terrence Malick.
That was so wonderful. I got this call from a person some years ago who said, I'm thinking about making a film about the history of life. Could I take you to lunch and we'll talk about it? And so I must admit, we go to lunch, and about halfway through, it dawns and I said, geez, this guy made Badlands. And, in fact, it was fun. Terry did make the movie very different from what David Attenborough would do, but I thought very compelling. It was just a joy to interact with him. He's a very bright person, very thoughtful. So that's just one of the little perks of being a geologist, I guess.
I'm sorry I didn't see that movie. I never did. The Tree of Life. It didn't really, it just didn't last long in the theaters, as I recall. It was.
Yeah, I mean, he made the Tree of Life, which actually my only movie credit comes, just before the Dolby Sound moniker at the end, where he thanks me because he does have some sort of like dream sequences in there that
Right.
do harkened on the past. But this was another movie that he made really for, more like natural history museums. And again, it didn't have a long lifetime where people could see it. I hope it comes back. For all I know, he may want to work on it more, but it was compelling, and it was more about the wonder of life. David Attenborough will tell you, the trilobites came in 500 million years ago and did this and that. And Terry's just takes you, you back off and say, my God, let's just think about the history of this planet. And I think there's a space for that kind of rumination as well.
I think the natural world figures quite prominently in his movies, Days of Heaven, and what was the World War II one when they were in? Wasn't Iwo Jima? It was Guadalcanal. Oh,
Yeah,
geez, big war
that's the
movie.
Thin Blue Line or
The
whatever.
Thin Blue Line, which was a novel, but what's really you feel in the movie is the jungle and the natural world. These guys with their pea shooters and cannons are obliterating, but really they're in the presence of something else. I went to Vietnam some years ago, not as a soldier. I'm not old enough, thank God. But one of the things that, having grown up in the shadow of that on the newspaper, he went to Vietnam, it was a nightmare. Oh my God, he came back, he was fucked up, he went to Vietnam. So I go to Vietnam as a tourist, and it's gorgeous. It's the Garden of Eden.
Mm.
Like, wait, I could live here. It's the women, the outfits, the jungle, the surf, the ocean, the food. What were they thinking? It was kind of a paradise, I thought, on many levels. So,
Well, I think everyone should have the opportunity at least once in their lives to walk through a tropical rainforest. It's like nothing else on this planet. And once you've done it, that will increase your reverence for the diversity of life that we have on this planet.
Yes, and they're big carbon capture mechanisms, those jungles and rainforests as well. Are they not?
Well, they have been. The interesting thing is that because of incipient climate change, certainly in the Amazon, that for when people measured it for many years, it was a carbon capture thing. But now, because there's less rainfall, you have more respiration. It's actually it's giving up carbon. So it's again things that were our friends in terms of various processes that keep the environment in check are not necessarily our friends anymore.
I always thought that preservation of forests and wetlands was a key component of survivability. You're suggesting here that maybe not. So I'm
well, no, I'm not suggesting that we shouldn't protect those areas. I think they're very important in many ways.
Right.
But it's just that in terms of the carbon cycle, the old idea that any rainforest will sop up CO2 is undermined by weather changes in these areas of rainforest as well. But I certainly think we want to preserve forests, preserve natural grasslands for many reasons. It has to be said that one of the biggest effects on the land is the huge percentage of the land surface that goes into agriculture and animal husbandry. And we need those. I mean, we have 8 billion people and we have to feed them, but there are consequences to that. And rather than saying, well, we shouldn't have agriculture, the two things I think we can say is that with agriculture, we probably have to take even more special care of the forests and things that remain.
Maybe there's a psychological component that there's a hopeful possibility if we do these things. We've seen examples where things regenerate, where things get better, because I've often felt it's hopeless, I'm depressed, forget it. And so you just, I don't know, it's not like you're marketing this, but there are narratives where things have restored, things get better. In our own rivers in California, they took down a couple dams up in Northern California. The salmon didn't even know how to help. They were back. Hey, we're home. Yeah. And hey, yeah, thank you. We're there. Good. Next week, 2 years later, they were there. During COVID, everybody was sequestered, and all of a sudden, the coyotes were coming out of the Hollywood Hills. I even saw deer on my street. It's like, wait, the humans are gone. Hey, we're here. We're back. Nature's fast, I think.
Yeah, it absolutely can be. Sure. Yeah. The other thing to think about too, because actually the amount of land surface that's been altered for raising of food animals is actually larger than the amount that's used for crops. And one of the things that we do have some control over is where we get our protein. And we need protein. There's no question about that. But, the amount of CO2 that's generated to produce a pound of beef is much, much larger than the amount needed to produce a pound of chickens or something like that. So one of the things that we do have some control over is our diets. And again, I'm not saying that everyone should give up having a steak. I like a steak every once in a while, but I think if we're thoughtful about what we eat as well as some of the other things in our lives, that can be useful.
Well, a lot of the water that's consumed in the West through, the aorta, which is the Colorado River, is agricultural production of alfalfa, which is to feed cattle.
Yes, right. That's right.
So it's not even just it's just the whole consumption cycle. Hey, I live in Hollywood. I like a good porterhouse once in a while over at Musso and Frank's, but I think it doesn't have to be a zero-sum game. Just cut it back. Just reduce it. It's a special thing. I sometimes think I look at my Asian friends. They don't eat steaks, but once in a while they chop up some meat in the vegetables, and it's a great flavor additive as opposed to, John Wayne's Red River beef, big slabs of it. Those are my thoughts. I don't know.
No, I agree with you. I agree with you.
Yeah, a couple more thoughts. I mean, this is such a deep subject, the origins of life, deep time. I'm completely enthralled by it. As a matter of fact, just to my right, I have my own little miniature natural history museum with little dinosaur bits. And, after reading your book, though, it's like dinosaurs, they're yesterday, 67 million years ago. That's nothing. And after reading,
let the record show that I like dinosaurs.
Okay, you're not against them.
They're the paleontologist's friend, but they're not the whole story by any means.
You mentioned The Day the Earth Stood Still and some of your favorite sci-fi movies. Did you see Project Hail Mary?
I haven't seen it yet. No.
Okay, then we don't need to talk about it. But it's this kind of crab-like creature, and it's this, interaction between Ryan Gosling and the crab-like creature. Was like, what? This kind of interstellar crustacean tools in on this massive spaceship, like huge, right? And like, I'm thinking, how the hell did they make that without opposable thumbs? But that was just like, I didn't get it. How they did that. As I think back on sci-fi movies, the one that was just massively huge was when I was a kid was 2001, which I saw it was the future. Now it's the deep past. But ultimately, it was looking forward to the revolution that we're in now, which is artificial intelligence.
Yeah, you're absolutely right. Hal wasn't some alien. Hal was a self-taught, computer device, basically. Yeah.
Right. And I'm curious how this new, whatever it is, I'm not sure, has affected your discipline.
It's coming. I was at dinner with some colleagues last night, and I was surprised that several of my colleagues who work on the chemistry of the Earth are using AI not to generate their ideas or write their papers, but just to, AI can find data for you very easily. Mm-hmm. And so it is certainly coming. I'm sure that people will use it to write, which is not my favorite thought, but yeah. It's happening. I'm no expert on it, so it's hard for me to see where it will be 20 years from now, but I'd imagine that many, many different disciplines, not just scientific disciplines, but everything, all sorts of things, screenwriting, for God's sake.
Oh my God.
Will be very much influenced by AI.
Yeah, I take comfort in the fact that whilst intelligence may now be artificial, stupidity is still real. So
yeah, maybe we'll get artificial stupidity too. That'd be a breakthrough.
Well, I was just curious because one of the things in your chapters was these experiments with this sort of primordial, let's say, Archean soup, and trying to recreate the chemistry and situations for let's get this life thing going, and there's you talk about the amino acids and these various molecules that come together and these membranes and just this, but there's still like some I don't know, divine spark that's we don't know about yet, or maybe we do and I don't know. But I was curious if maybe there was some AI sort of computational wizardry that could help understand that in a better way.
I'd also almost be surprised if there weren't someone out there trying to make that happen, because one of the things you'd like to know is how different molecules interact. And you can go to the library and say, oh, this molecule and this molecule will do this, and in that same time interval, AI can show you what a million different molecular combinations do. So that's a place where it might actually provide some insights.
Right. And I'll be hopefully around to find out. Andrew, you're so cool, man. Yeah, I so
Thank you.
appreciate, I didn't get into Harvard. I applied. I had to go to Berkeley. So, I got my own private seminar here with one of the biggest of all time natural history brainiacs. So I'm totally appreciative.
Well, it's been fun.
Yeah. Quick question as you look into the future. I mean, one of the things I appreciated about your books was that you were reaching from your ivory tower to the hoi polloi, us, because I feel like this understanding of our world shouldn't be cloistered and sequestered in the academic silos. They need to be shared. And as what you did is an important part of that project, in my view. So,
well, thank you. I think, for me, on the one hand, I think the story of our planet is wonderful. And I think, you want to know the story of the Earth, the same reason that you want to read Shakespeare. It just makes your life better. And I like sharing that. And again, if people understand better our planet's history, they may actually think more wisely about our planet's future. And so, I have no interest in writing a book for the 10 people who do what I do. I would much rather try and reach a broad audience and help people to appreciate what a wonderful planet we live on.
Yeah, from eukaryotes to Hamlet.
Yeah, that direct line.
Yes, it's a direct line. Alas, for your Horatio, I knew him. I have a series, I'll let you go, called Shakespeare in the Shower, where I do my favorite monologues in the shower. I've done like 10 or 11 of them.
Oh, cool.
Yeah, it's like, I want to play these parts. I want to do this. Andrew Knoll, first, I want people to check out these books. You need to read them. Earth and Life, a 4 billion year conversation, and also A Brief History of the Earth, which is probably the most impressive condensation of time into book ever accomplished. Thank you for sharing your scholarship, your insight, and the whole thing.
Thank you, Bill.
Until next time, namaste, shalom, and aloha. By that I mean namashaloha. See ya.